heart went.
Hi! So, bago natin aralin yung combination circuits, so we can clear out your confusions on series and parallel connections, aralin muna natin si voltage divider principle. So, what is voltage divider principle? Voltage divider principle is a technique that we were able to notice or a pattern that we're able to create whenever nagsosolve tayo ng series resistances. Specifically, two series resistances. Okay, so let's say we have a series circuit that contains a voltage source with your positive and negative terminals, and we represent this as variable E or your total voltage VT. Let's say this is in series with two resistors. Let's say we have resistor 1 and it is in series with another resistor. Let's represent that as resistor 2. Kung di pa natin alam si voltage divider principle, tapos binigyan tayo ng problem na ganito, that you have two series resistors with an applied voltage VT, tapos hiningi sa atin ano yung voltage drop sa resistor 1 at sa resistor 2. What we do before is take the total resistance. For that, you will get RT. And for series connected, ang RT natin, sum lang siya ni R1 at ni R2. Okay, so now that you have total resistance, knowing that you are already given total voltage, pwede na natin kuhanin si I total, and by Ohm's law, that's VT over RT. Pag nakuha mo si IT, meron ng current na magpa-flow dun sa circuit natin, and we know that this current is the same current that flows through R1 and R2, which is I1 and I2. So let's say here, we have I1, and on the other resistor, we have I sub 2. Having quantities on these parameters, pwede natin kunin yung voltage drop kay R1, which is V1, and by Ohm's law, that's VIR, that's I1 R1. And the same goes for resistor 2's voltage drop, which is V2, that's IR ulit, kaya I2 R2. So, since alam natin that voltage may only be divided if it is connected in series, kasi alam natin kung parallel connected siya, voltages will be equal. So, it is not necessarily divided kapag parallel yung connection. Kaya naman, pag series lang natin, pwede i-apply si voltage divider principle. So, kagaya ng sinabi ko kanina, si voltage divider principle, isa siyang pattern na nabuo natin knowing that, halimbawa, hiningi ulit sa atin yung voltage drop ni R1, knowing the idea that if it is series connected, yung current mo kay R1, which is I1, that will also be the current that flows through the circuit, which is I total. Ngayon, if I try to use Ohm's law to solve this equation, we know that I is equivalent to V over R. So if I solve for I sub 1, that would be V over R also, but that would be V1 divided by R1. And that would be equivalent to IT, which means pwede ko itong i-substitute with V over R ulit, where V is VT, and R will be R total. Or instead, pwede mong palitan si VT ng E, since that represents EMF, equivalent to the applied voltage over RT. At maalin sa dalawa, pwede nating gamitin. Now, having this equation, pwede ko nang isolve si V sub 1 in this, with V1 equal to VT, multiply natin si R1 doon, R1 over, you have the denominator RT. Okay, so what is RT? Diba kung series connected yan, si RT, sum lang naman yun ni R1 and R2. Therefore, we'll have V1 equal to VT times R1 divided by the total resistance, which is simply R1 plus R2. And that gives you the formula that we can use to solve for the voltage drop in the first resistor. So, instead of doing it this way, instead of solving for the parameters individually like RT, which is R1 plus R2, tapos if you have RT, pwede na natin kunin si IT, and that would be equivalent to the current in the circuit, I1 and I2, makukuha mo na si V1, which is equivalent to I1 R1. Instead of doing that, pwedeng ganito na lang yung gawin natin. So, para makuha natin yung hatian ng voltage between two series resistances, for the voltage drop of resistor 1, that would be equivalent to total voltage, the applied voltage in the circuit na paghahatian ng ating resistances, multiplied by, kung V1 ito, resistance ni 1, divided by sum nilang dalawa. So, if I will be solving for voltage drop at resistor 2 naman, ganun pa din. Total voltage na paghahatian times yung V1 R1, so yung V2 R2 naman. Divided by, same pa rin. R total, that is R1 plus R2. Naging shortcut solution natin si voltage divider principle since hindi na natin kailangang mag-solve pa ng current pag naghahanap tayo ng voltage drops. Ang kailangan na lang nating alamin is ano yung dalawang formula na gagamitin natin. So, ang technique for voltage drop ni resistor 1, that is applied voltage times ni R1 divide sum ng dalawang series resistor. Kung voltage drop ni R2, applied voltage ulit times si R2 naman. Divided by the total resistance ulit. Let's learn to apply VDP on a simple example. So let's say we have a 10 volt source. And then let's say this is a 2 ohm resistance. And the other one is a 3 ohm resistance. If hindi natin alam si voltage divider principle, ang gagawin natin is kuhanin natin yung total resistance natin. That's R1 and R2. So 2 plus 3. We have 5 ohms as our total resistance. And then, we get I total. That is VT over RT. So, VT is 10 volts divided by 5 ohms. We get I total equal to 2 ampere current. So, this 2 ampere current, which is your I total, will also become your current in R1 and your current in R2. So, yung ating IT, equal na siya kay I1, also equal to I sub 2. And getting the current flow, pwede ko nang isolve si voltage drop 1, and that would be I1 R1. So, we have 2 amperes multiplied by what is R1? R1 is 2 ohms. Therefore, we get V1 equal to 4 volts. And then we can solve for voltage drop 2, same process. That would be I2 times R2. I2 is equivalent to 2 amperes and R2 is 3 ohms. So we have 6 volts. Or alternative natin kay V2 is, di ba alam natin that V total is equivalent to V1 plus V2. Meron na tayong VT, that's 10 volts, and V1, na-solve natin as 4 volts. Ibig sabihin, pwede nang kunin si V2, and that would be 10 volts na VT, minus transpose mo si V1, which is 4 volts. So, we'll get V2, 6 volts din. So, that was our conventional. But alternatively, we can use VDP, voltage divider principle. And for me to get V1, anong sabi? Total applied voltage. So, 10 volts yon multiplied by, kung V1, si R1 ang kailangan ko. So, 2 ohms divided by sum nilang dalawa, which is 5 ohms. And that gives you 4 volts. For V2, ganun ulit. Magkano yung voltage sa paghahatian? 10 volts times pag V2, R2 naman ang kailangan natin. So, 3 ohms over, sum ulit nilang dalawa, 5. We have an answer which is 6 volts. So, para sa atin, this is shorter. Diba? Kasi you do not have to go through the hassle of getting R total, I total pa, bago ka makakuha ng voltage drop, diba? Para sa atin, this is easier. So, gusto ko lang i-emphasize na si voltage divider principle, pwede lamang natin siyang gamitin for two resistances which are connected in series. Kasi, syempre, diba, alam natin na pag parallel, equal yung voltages. So, ibig sabihin, series connections lang natin pwedeng apply si voltage divider principle. Okay, so, this time, ang aralin naman natin is current divider principle. So, there's a similarity with a voltage divider principle. Since si current divider principle po is also a pattern or a technique that we notice when we have two branches that are connected, in this case, parallel naman po siya. So, two branches connected in parallel. Okay, so let's say we have An example, simple parallel circuit with an applied voltage of VT or E para sa EMF. And let's say this is connected in parallel to two branches. Let's say the first branch is R1, ang laman. And let's say yung second branch natin, si R2 lang ang laman. So, kung halimbawa sa example na to, hiningi naman sa atin yung current na nagfo-flow dun sa branches ni R1 at ni R2, ang ginagawa natin dyan is simply apply basic laws of parallel circuit. And number one of that would be equal voltage principles ng mga branches. Get voltage drop at R1, we have to find out parallel branch with voltage. So, VT yon. And for R2, dun din siya nakaparallel kay VT. Kaya yung voltage drop sa R1, R2 mo, equal siya kay total voltage VT natin. Ngayon, since we already have V1 and you have R1 given, pwede na natin kunin yung current na nagpa-flow dito. Same goes for the other branch, ano? So, here we have I1 and on the other hand, we have I2. And if we get I1, we apply Ohm's law and that would be voltage V1 divided by resistance in that branch which is R1. And for I2, we have V2 over R2 naman. Pero what if total voltage is not given or is not specified? What if instead, total current yung ibigay sa atin? Yung total current na papasok dun sa junction na paghahatian ni branch 1 at ni branch 2. So, kung I total lang yung given sa atin, paano ngayon natin malalaman kung paano siya paghahatian ni R1 at ni R2 or nung dalawang parallel branches? For that, balik tayo sa principle ni parallel na equal voltages. So, if V1 is equivalent to the total applied voltage VT, under Ohm's law, I can substitute IR. So, for V1, that's I1 R1 equal to, for VT, we have I total R total. At ito yung given sa atin, IT instead of VT. So, from the above equation, if I solve for I1, that would be equivalent to the right side, which is I total R total. And then divide it by R1 since we have to divide both sides by R1. And ngayon, since this is already given and you have R1 given here in our circuit, we need to solve for R total first para makuha si I1. And for a parallel connected circuit, for parallel, to get the total resistance, that would be equivalent to the reciprocal of the sum of the reciprocals of parallel branches resistances. Ibig sabihin, para makuha natin yung total resistance ng two-branch parallel circuit na to, kailangan mong i-inverse si R1 plus inverse ni R2. Yung answer natin inverse ulit to get RT. So, we'll get LCD. The fractions in the denominator, and that's product of R1 and R2. And then, we have R1, R2 divide R1. That would be R2 times 1. We have R2 plus, we do the same, R1, R2 divide R2 times 1. We have R1. With that, we take reciprocal of our answer to remove the mixed fraction. So, R total now becomes R1, R2 all over, pag na-reciprocal, ayusin ko lang, R1 plus R2. Inuna ko lang si R1. Since commutative naman si addition. And then, after that, I will be using this value to substitute in the previous equation of I1. So, I'll have I1, that would be equivalent to I total na multiplied by RT. So, ang RT natin ay R1, R2, all over R1 plus R2. And then, this will all be divided by R1. And then, you will notice that R1 appears in the numerator and then also in the denominator, so we can cancel that out. And then to simplify, you will get I1 equal to I total times R2 divided by R1 plus R2. Ngayon, kung keen observant ka, mapapansin mo that for me to solve for the current in the first branch, that would be equivalent to the total current that will enter the junction or yung current na paghahatian nilang dalawa multiplied by, if I'm solving for the current in this branch, yung kabilang resistance ang gagamitin ko, that's R2. Kung I1 ito, R2 dapat yun yung kabila. Divided by, same, sum ng R1, R2, parang sa voltage divider principle. Sum ng dalawang resistance na maghahati dun sa current. Therefore, if I'm solving for I2, that will still be current na paghahatian multiplied by, kung current sa R2 ang hanap ko, yung kabila ang gagamitin, that's R1. Over, ganun ulit, R1 plus R2. So, si current divider principle, mapapansin mo, yung formula niya, halos kaparas ni VDP, ba diba? Ang difference lang is, pag VDP, directly proportional. Pag hinanap mo si voltage in the first resistor, si resistor 1 din gagamitin mo, voltage 2, R2 din. Pero kapag current divider principle naman siya, for I1, yung kabila, R2 yung gagamitin mo. And then for I2, yung kabila ulit, which is R1. Yung denominators naman, parehas na R1 at R2. Si VDP nga lang, R1, R2 for series resistances, tapos si CDP naman, R1, R2 of parallel branches. Can summarize what we learned. And VDP, therefore, can be used for series only. And CDP, on the other hand, will be used for parallel connections only. So, para makuha natin under VDP yung voltage sa first resistor, that would be the total applied voltage multiplied by kung V1 to R1 over sum, R1 plus R2. Ngayon, kung ang isasolve ko naman ay V2, parehas lang, applied voltage ulit, VT times, kung V2, R2 naman, divide R1 plus R2 ulit. Ngayon, kung current divider principle ka naman at parallel connected yung circuit, ibig sabihin current ang kukunin mo. Pero pag VDP, voltage divider, voltage dapat. Ngayon, to get I1, that would be the total current that will enter the junction multiplied by, kung I1 ang hanap, dapat yung kabilang resistor ang gagamitin. That's R2 over R1 plus R2, or the sum of the resistances of the branches in parallel. For I2, parehas lang, current in the junction times kabila, that would be R1 over R1 plus R2 ulit. Let's have a clarification on the use of loss in parallel circuits. Okay, so let's say we have an example circuit. Let's say our circuit consists of a DC voltage that is rated 20 volts. Tapos sabihin natin itong voltage natin, naka-parallel siya to a branch, a single branch that consists of a single resistor, and let's say this is R1. Tapos naka-parallel ulit siya to another branch, na yung branch na yon has two resistors in it. And let's say si R2 at si R3 yon. Okay? Let's assign value. So, for R1, sabihin natin 4 ohms ito. Tapos, let's say R2 is 2 ohms. And then, let's say R3 is 3 ohms. Okay? Now, the circuit that we have here is considered a combination circuit. Bakit daw po? Because alam natin, this looks like a parallel circuit. You have two branches connected to 20 volts. But, if you're going to notice the second branch, it has two resistances which are connected in series na nakalagay sa kanya. Therefore, series parallel ang combination natin. Ngayon, papasok yung error natin dun sa first law of parallel circuit. Bakit? If we apply a voltmeter here, let's say that's V2, di ba? Pag voltmeter, dapat parallel connection. And then, let's apply it again to R3, that's V3. Thus, this voltmeter will read the voltage drop in R2. And the other voltmeter will read the voltage drop in R3. Kaya naman, pag nire-represent natin, yung voltage drop kay R2, V2 yon. Yung voltage drop kay R3, V3 yon. Ang kaso, kapag pumasok ka kay parallel circuit, first law, binuklat mo yung libro mo, nakalagay doon, VT is equal to V1 is equal to V2 is equal to V3. Kaso, ni-note ko na malinaw na ito ay pwede nating i-apply kung branches ang pinag-uusapan natin. Ngayon, kahit pa meron ka ditong V2 at meron ka ditong V3, hindi mo pwedeng sabihin at sundin na ang V2 will be equal to V3 according to the formula. Bakit? Dahil itong R2 at R3 mo are connected in series. They are not parallel. Also, they are on a single branch. So, hindi sila magkaibang branch para masabi mo na V2 will be equivalent to V3. Kasi hindi equal si V2 kay 20 volts at hindi rin equal si V3 kay 20 volts. Yung V2 na nandito, hindi yun yung V2 na tinutukoy ng ating formula. At ganun din, yung V3 na nakita mo dito sa circuit mo, hindi yun automatic equal dun sa V3 na binabanggit ng formula ni parallel circuit. Tatandaan, yung laws po ni parallel circuit ay applicable lamang kung branches ang pinag-uusapan natin. Ngayon, ito po ang ibig sabihin ng circuit na meron tayo. So, it is true that we have an applied voltage VT that is 20 volts. Ngayon, itong VT po na ito, siya ay equal din kay V1. So, halimbawa, magkakabit tayo ng voltmeter across R1, di ba? Ang representation na natin doon, V1 yun. So, since yung branch kung saan nakakabit si V1 ay parallel kay 20 volts, ibig sabihin, so lang matatanggap ni R1 yung 20 volt supply. Pagdating mo sa second branch naman, yung ating V2, hindi na siya equal kay V3 ha. Remember here, since series yung dalawa, V2 will never be equal to V3, but instead, as a whole, ng magkasama or together, they will receive the 20 volt supply since yung buong branch na yun is parallel to this applied voltage. So, parang ang nangyari dyan, halimbawa, hiniwalay natin, 'di ba? Pwede nating sabihin 20 volts is connected dun kay R1 natin. Tapos you have another circuit na 20 volts din. Tapos connected siya dun sa kabilang branch na R2 and R3. So kung titingnan mo yung itsurang ito, parang itong circuit na to naging series siya, 'di ba? Kaya naman, yung voltage 2 natin hindi na siya equal kay V1. And yung voltage 3 natin, hindi rin equal kay V2. At kita mo naman na series connected to. At alam natin, di ba, pag series connected ka, yung sum ng voltages nitong dalawang to, R2 and R3, will be equivalent to the applied voltage. For sa case na ito, yung VT mo na 20 volts, that would be equivalent ngayon sa sum ni V2 at ni V3. So, para sa problem na to, pwede na tayong gumamit ng voltage divider principle dito para makuha natin si V2 at si V3. Hindi na natin kailangan mag-solve ng current, diba? So, if I'm going to use VDP, solving for V sub 2, that would be the applied voltage, VT, multiplied by R2 over sum ng series resistances na maghahati, and that is R2 and R3. So, if I substitute, ang magiging V2 ngayon natin ay applied voltage is 20 volts multiplied by, sinong hinahanapan ng voltage? Si R2. Kaya 2 ohms yan over sum ng dalawang nakaseries. That's 2 plus 3 ohms. Therefore, we'll be able to get V2 which is equivalent to 8 volts. Tapos, pwede tayo mag-VDP ulit para naman makuha si V3. So, ang V3 natin would be equivalent to the applied voltage ulit. Kung saan tayo kumukuha ng voltage, that's R3, divided by the sum of the two series resistances, R2 and R3. So, V3 will be equal to 20 volts times what's R3, that's 3 ohms, divided by 2 plus 3 ohms ulit, which is 5 ohms. Makuha natin si V3 ay equal sa, and that is 12 volts. Pero kung gusto mo ng alternative solution to this, mas maigsi, pwede tayong bumalik dun sa principle ni series, 'di ba, na yung sum ng voltages, or ito, balik ka dito sa equation na to, 'di ba, pag tinranspose mo si V2 sa kabilang side, makukuha mo na si V3. Therefore, yung V3 ngayon natin, that would be equivalent to 20 volts minus transpose mo si V2. Ano ba yung V2 na na-solve natin? 8 volts. So, ang sagot natin, 12 volts pa din. Parehas pa rin. Now that we have the voltage drops, let us summarize the values that we have. So before that, let me erase this first. Okay, so to summarize the values, we have VT na, that is 20 volts. And that's equal to V1. And then nakuha natin si V2 which is 8 volts. And then we already have V3 which is 12 volts. Ngayon, para makuha naman natin yung current that flows through the branches, alam natin that we will have an I total supplied from the source. Okay, itong IT na to, papasok siya dun sa junction, mahahati siya. So, meron tayong current na papasok dun sa first branch, and then the other current will flow through the other branch, at yung current na papasok dun sa first branch natin, we can name that I1, and then yung current dun sa second branch natin, that could be I2. At along that, we have I3 then since it's connected in series. And then since may V1 na tayo, pwede na nating isolve si I1. And that would be equivalent to V1 over R1. And that is 20 volts for V1 divided by R1, which is 4 ohms. So we'll get I1 equal to 5 amperes. And then for I2, that would be equivalent to I3 since series yung dalawa natin, di ba? So, ang I2 natin would be equivalent to V2 over R2. Ang V2 na na-solve natin ay 8 volts divided by R2 natin, which is 2 ohms. We'll get I2 equal to 4 amperes. Pwede mong i-check si I3 using V3 over R3. Lalabas na equal pa rin yan sa 4 kasi you have V3 which is 12 volts divided by R3 which is 3 ohms. So, ang sagot natin 4 amperes pa din. And the explanation to that is because they are series kaya equal silang dalawa. And therefore, yung ating solution used voltage divider principle. Okay, so this time, let's try to have an alternative way of solving the circuit. And by that, we start with getting the total resistance of the given network. Ngayon, for us to get the total resistance, we have to simplify this branch first, ano. So, since you have a series connection here of R2 and R3, diba, we have to take their sum. Pwede natin gawin dito, i-redraw natin yung circuit, i-simplify natin yung branch na yon. So, we still have 20 volts parallel to R1, which is 4 ohms. And then, the second branch may be represented into one resistor na lang. And for the sake of our representation, pwede nyo naman pangalanan niya ng bago, diba? Let's say RA naman yun. Kayong bahala sa subscript nyo. Pwede din namang wala, ano. So, RA will be R2 plus R3. Substituting, that would be 2 plus 3 ohms. So, in total, yung bagong resistor mo, 5 ohms na siya. Now, we have two parallel branches na. And for us to get the total resistance, that would be 4 inverse plus 5 inverse. Our answer, inverse. And RT will be equivalent to, and that will be equivalent to 20 over 9 ohms. So, kung meron na tayong R total na 20 over 9, pwede ko nang kunin si I total. That would be equivalent to VT over RT. What is our applied voltage? That's 20 volts. Divide it by our total resistance, which is 20 over 9. So, cancel si 20. Inverse, we get IT equal to 9 amperes. And itong sagot natin to, this is the same as the sum of the current na meron tayo kanina dun sa previous solution. Sum ni I1 at ni I2. Di ba yung I1 natin ay 5, yung I2 natin ay 4. So, pag pinag-add mo yun, that would be 9 amperes. Okay, same. Pero, if I'm going to solve the current here in this circuit, so we have I total na, and then I have I1 on the first branch. On the second branch, I have I2 for R2, tapos I3 for R3. I can use, for I1, I can use current divider principle. So, to get I1, anong sabi? Total current na papasok. So, that's 9 amperes multiplied by, pag I1, resistance sa kabila. But since doble to, kailangan simplified siya. So, ang gagamitin natin yung 5 ohms over yung sum ng dalawang resistor na nakaparallel. That would be 4 plus 5. Okay? So, I1 will be equivalent to 5 amperes and that is the same answer na meron tayo sa previous solution kanina. Then, for I2, let me use CDP ulit. So, we use total current and that is 9 amperes multiplied by, for I2, kabilang resistance, that's 4 ohms divided by sum nung dalawang parallel branch resistances, that would be 4 plus 5 ohms. We get I2 equivalent to 4 amperes. Ngayon, kung kukuha na naman natin yung total current, since we already have I1 which is 5 amperes, I2 is equivalent to 4 amperes. And it is series to I3, diba? To R3, so I3 is 4 amperes also. Ngayon, IT will be equivalent to I1 plus I2 dahil itong current naman nito, nahati siya sa dalawang branches lang. Therefore, we're going to follow
principle of parallel circuit. So, since 2 branches lang yung meron tayo dito, kunin mo lang yung current sa first branch, that's I1, isama mo lang yun dun sa current ng second branch mo. Since dalawa yung nandyan, pumili ka lang ng isa kasi iisa naman yung value nilang dalawa. So, for IT, that would be 5 amperes for I1 and 4 amperes for I2. You'll get IT equivalent to 9 amperes pa rin. Although, na-solve na natin siya kanina, diba? Ngayon, kung sinabi ng formula mo sa parallel na IT is equivalent to I1 plus I2 plus I3, hindi mo siya pwedeng gamitin sa circuit na to. Kasi po, kahit meron ka dyang I2 plus I3 sa formula, tapos meron ding I2, I3 sa circuit mo, but since parallel ang sinusundan natin, dapat dalawa lang yung current kasi dalawa lang din naman yung ating branches. Nagkataon lang dito, you have I2 and I3 dahil nga, nirepresent natin yung per resistor in the branch. Okay, so tatandaan sa parallel po, kung ilan lang ang branches, ganun lang karami ang current sa equation mo.